Today we're going to talk about sampling. We have learned ways to display, describe, and summarize data, but have been limited to examining the particular batch of data we have. We'd like, and often need, to stretch beyond the data at hand to the world at large. Let's investigate three major ideas that will allow us to make this stretch. The first idea is to draw a sample. We'd like to know about an entire population of individuals, but examining all of them is usually impractical, if not impossible. We settle for examining a smaller group of individuals, a sample, selected from the population. Sampling is a natural thing to do. Think about sampling something you are cooking. You taste a small part of what you're cooking to get an idea about the dish as a whole. Opinion polls are examples of sample surveys, designed to ask questions of a small group of people in the hope of learning something about the entire population. Professional pollsters work quite hard to ensure that the sample they take is representative of the population. If not, the sample can give misleading information about the population. Randomization can protect you against factors that you know are in the data. It can also help protect against factors you are not aware of. Randomizing protects us from the influences of all the features of our population, even ones that we may not have thought about. Randomizing makes sure that on average, the sample looks like the rest of the population. Not only does randomizing protect us from bias, it actually makes it impossible for us to draw inferences about the population when we see only a sample. Such inferences are among the most powerful things we can do with statistics. But remember, it's all made possible because we deliberately choose things randomly. How large a random sample do we need for the sample to be reasonably representative of the population? It's the size of the sample, not the size of the population, that makes the difference in sampling. If the population is small enough and the sample is more than 10% of the whole population, the population size can matter. The fraction of the population that you've sampled doesn't matter. It's the sample size itself that's important. Why bother determining the right sample size? Wouldn't it be better to just include everybody and sample the entire population? This sample is called a census. Well, there are problems with taking a census. It can be difficult to complete a census. There always seems to have some individuals who are hard to locate or hard to measure. Populations rarely stand still. Even if you could take a census, the population changes while you work, so it's never possible to get a perfect measure. Models use mathematics to represent reality. Parameters are the key numbers in those models. A parameter that is part of the model for a population is called the population parameter. We use data to estimate population parameters, and any summary found from the data is a statistic. The statistics that estimate population parameters are called sample statistics. In statistics, we have the following things that we typically are trying to find: mean, standard deviation, correlation, regression coefficient, and proportion. Now, when we're talking about the population mean, we're going to use mu. Population standard deviation is sigma. Population correlation is rho. Regression coefficient for the population, we're talking about the slope, we use beta. And proportion, we use either p or pi depending on which textbook you're using. However, when we're talking about the sample, the symbols are x bar for the mean, s for the standard deviation, r for the correlation, b for the regression coefficient, and p hat for the proportion. Let's take an example. Dairy inspectors visit farms unannounced and take samples of the milk to test for contamination. If the milk is found to contain dirt, antibiotics, or other foreign matter, the milk will be destroyed and the farm re-inspected until purity is restored. So the population that we're dealing with is the milk produced by a dairy farm. The parameter of interest is whether or not the milk contains dirt, antibiotics, or other foreign matter. The sampling frame, which is where are we getting the data from, is the milk produced by the farm on any given day. And the sample is the milk produced by the farm on the day of the inspection.